pass over to Jeremy. Jeremy, all.
Hello, everybody. So I'm Jeremy Yates, and I'm the joint lead of the ExCALIBUR hardware and enabling software program, along with Simon, who spoke earlier. So here is the corporate slide, where we are a UKRI project, and we are your kind of help. Yes, it's done it right. Okay. So here's the first slide, and this is an organogram that I and Martin Hamilton did just to kind of show you how ExCALIBUR is organized. This is the kind of main stuff up here, the project board and the steering committee, which Simon sits on. Over here to the right, these are the projects, which is the software projects. And then below the dotted line is the hardware and enabling software project. We have a delivery board, which is chaired by Simon, and then we have a technical working group chair, which is chaired by John Taylor of Square Kilometre Array project. We have a technology providers panel, which is vendors for anyone who wonders what a technology provider is, and that is chaired by Dave Lecombe from ARM. We also have a benchmarking project, which sits under the technical working group, and that is coordinated and run by, or will be coordinated and run by, Andy. So Andy's very involved in the hardware and enabling software program. Over to here, you have the various projects over to the right, you have the various projects that we are funding, and you see this line between the software projects and the hardware and enabling software projects, and you'll see this mysterious phrase RSE-led interaction. And I think what I'm trying to get across here is the main interaction between the software projects and the hardware projects will be done by RSEs on both sides. So you've already had this, Simon's already been through this, but I want to get across to you that the exascale definitions we will be using are activity-based, solving problems that are 10 to 1,000 times larger. 10 is what is me referring to what Ian was calling the FFT problem, and again, solving problems faster than the present. Problems can be simulation, data modeling, and/or data-driven. Can come from all areas of research and innovation. And exascale velocity, this is kind of what Ian was talking about, that a lot of the work that we will be doing at the moment should have a direct impact on the petascale region, because we should be able to do things a lot faster and to much more accuracy before the exascale systems arrive. The approach, again, Simon's been through this. Just to remind you, we've had £4.5 million over 4.5 years. And we've already started to allocate money for projects. So these are the projects that we've done. So UCL for interconnect testing. So we've actually built, or about to build, a 64 I want to say node. I don't mean that, but an interconnect rig that will contain space for 64 nodes. But the main thing is that it will contain both 100G Ethernet with a latency of 2 microseconds between the servers via the switches, but also a big 200 gigabit per second, 1 microsecond IB layer. Note what I just said. Ethernet's rapidly catching up with InfiniBand, and that's quite an important thing to bear in mind, which is why we're having both. And there'll be an ARM, and we bought the ARMforge parallel debugger, although I hope we end up getting it for free, which will be available to you all next week. And as Andy's just pointed out, if you have a bespoke version of Ethernet, then you can actually do a lot better than 2 microseconds. So things are moving there, and it's good because it means that things are going to get cheaper and much more easier to kind of maintain and also drive developments. Durham is looking at exascale solutions for storage and RAM as part of Fabric services, and we're also going to deploy a and we're also going to deploy an AMD system. Leicester are going to look at the ARM processors, and I think they will do that with Bristol, and just to have a look at application performance. Cambridge are looking at, and this goes to Alan's talk, are actually building systems to test and tune file systems like DAOS and other things, looking at block storage and object stores for exascale systems, and also additionally how cloud OS operating systems like Scientific OpenStack will work on exascale systems. And then Edinburgh and Bristol want to look at improving our application performance by actually looking at in depth at the communication properties for a range of processor unit and accelerator systems. I tend to use the phrase PO plus accelerator rather than CPU plus GPU and that kind of thing. And also testing and improving APIs for a range of processor unit and accelerator systems. So how are we going to work with you? Well, we've done this back to front, and the main reason we've done it back to front, of course, is so we have to get the money out of the door. So each hardware and enabling software project will have an RSC and ResOps kind of person or people, and they'll be the main interface with the software project. Benchmarking is going to be the key activity, let's face it, and Andy Turner is our coordinator. Andy will go into this in much greater detail, so looking at synthetics, mini apps, as well as the applications themselves where we can. I and Simon are going through all the software proposals, and we're doing our best to reduce them to what we call, what I call min-appy functionality. So, in a sense, what combo of the dwarves are you trying to do, just to kind of get a baseline. And this will be a useful document, I feel, for all the projects, as well as in the hardware and enabling software projects. Based on that, we'll start to ask you what technologies you'd like to use now, and you can view our systems as analogs. So, for instance, our adaptable cluster, we now know how to put in delays, which might sound very odd, but we can start to build analogs of what an exascale system might look like. So we can start to allow you to test various aspects of your code on that before larger systems arrive. Okay, because larger systems cost a lot more than £4.5 million. And also see what technologies you'd like to see put in place. And a technology can be both hardware and software and middleware. That's the important thing. It's not just hardware. And what I call sort out routes. So one thing that we're doing is working out where you can take your code after you've done your initial development, where you can actually take it to actually try and run it at some kind of scale. So we are going to have an activity that does that. Just to remind you, what we are setting up the calls. Dirac managed to was basically awarded this project in the first place. That has now been seen to be not a good idea. So now it's a true UKRI project. But in order to get the money out the door, we've placed £500,000 with some Dirac projects. £1 million is going to be placed with Dirac and non-Dirac collaborators, and then we hope in the autumn to announce truly open calls. And at this stage, we want to be directly linking in or responding to the software calls as well. So it's nice to finally meet a project. I've read all about you, but it's good to meet you all, and good to start going with you. That's it.
Thank you, Jeremy. If there's any questions, please